So I thought about it and made the decision. I thought it was going to be. I could have continued a little bit more with a stylometry because we have some related results showing that the same lack of privacy, the same linkability works also for microblogging, in particular for Twitter, and we've done some extensive studies. But I think you would be a bit more bored with that because you already heard enough about, you've seen enough charts and graphs and linkability ratios. Just sort of trust me that linkability also works for Twitter, even though Twitter has a very small and strict limit on characters, and people tend to use very limited kind of a restricted language in tweeting. But yet, given enough tweets, we can link multiple accounts on Twitter. And actually, the only sort of interesting thing I can tell you about that study is that on Twitter, we were able to identify people who own multiple accounts. We had some ground truth. And the reason is because some people actually announce, or they leak that information themselves. We didn't force them to divulge it. So there were like 30-something or 30 or 40 accounts that we knew were operated by, let's say, the same dozen people or so. So we could actually test our linkability experiments or run our linkability experiments on those people and verify our results. Okay, so that was different because with Yelp we didn't have that information, that ground truth. Okay, but now something completely different, but also related to social networks. And this is about social networks that are not online, right? Rather, social networking in a world that is a little different from the way it is used today. And this is joint work with one of my former PhD students and a visiting PhD student from Germany, so from a couple of years back. Okay, we'll skip this because it's the same. This is the outline. Privacy preserving. Right? So okay, this is a little bit of an overlap between the two talks. You all know about all the OSNs, right? And I already told you what I think about them, on my skeptical view of social networking. But the question is now, this is different. Has social networking reached its limit? Right? People are born, they grow to a certain age. I don't know what is the right age is, but at some age, usually about 12, 11, they start getting into social networking. Now, maybe it's not Facebook because, according to my youngest daughter, Facebook is for boring adults. My older daughter grew up with Facebook, so for her it's really hip and exciting. But you can see and then the difference between them is 10 years, and there's like a 2 generation, right? So they really have very different views of social networking. And they do agree on Instagram, though. But like one is using Snapchat, the other one wouldn't touch a Snapchat with a 10-foot pole, and all kinds of other things. One uses Signal, the other one does not, so you know what Signal is, right? That's a super secure encrypted version of WhatsApp, basically. It's a secure messaging system. Anyway, one of them inherited my genes, the other one probably didn't. Anyway, so, but see, what I'm trying to say is that, okay, the social networks change. So something is popular today, next year there'll be some other social network is a little hipper, a little sexier, a little more appealing to the younger generation. But yet, we don't see any big shifts, right? So the new generation, people grow up, they get to this age when they start using social networks, then people get older and older, and so you have today even sort of grandparent types who are using Facebook and LinkedIn, etc. And then what? Well, people die, right? And presumably social networking ends for them. Well, not quite, right? So what could be next is OSN for pets. Actually, it's not next. It's already here, right? Where the people, instead of creating a social network persona for themselves or their presence, they create it for animals. I always find it a little strange. I think there's like people who maintain accounts for their dogs and cats and parrots, they need some therapy. Or maybe it's a self-therapy, actually.
Yeah, most of them on Instagram, they get paid for it. If they have
Oh, yeah?
Yeah.
I hadn't thought of that. That's probably true.
Yeah.
You know, there could be OSN for like inanimate objects. Like people, why not? If I have a favorite chair, I could create a account for my favorite chair, post pictures, right? Why is it always the cat? Well, it could be a stove.
Yeah,
A car, yeah. I mean, I don't see a lot of women do that, but you know, I can see a lot of guys, you know, say my Harley, you know, yeah. I don't know. I mean, maybe the ladies here could tell me what you might imagine women doing, you know, but guys would certainly do things like cars, right, or a soccer ball. You know, here's my soccer ball at this webpage. You know. Okay, but this is of course weird. My view, right, is that one place we haven't gone is the social networking for offline world. And I'll tell you in a second what I mean by offline world, but let me first tell you what I think where else it possibly goes. What about OSN for the dead? Right? So forget the chairs and cars and motorcycles. Think about it. There are a lot of dead people out there. Right? They're more dead than alive. In fact, so there are two types of dead people. One type of dead person died recently, meaning they used the social network, they had a Facebook page or a VK page or LinkedIn, and then they died. And then there's this whole area of research, and some of my colleagues in HCI and this area more of touchy-feely computer science, they look into like what happens to those accounts, like who inherits the account. Your grandmother, I'm sorry, not your grandmother, somebody's grandmother dies, and you know, who inherits the account? Maybe memorials, put, you know, some little pictures of flowers and, you know, and so on, that people write condolences. So for a while, you can imagine the accounts could live. But this is not very exciting. I mean, they're just, okay, you had a person who used the social network and then they died. But what if we consider people who are dead but never lived in the age of social networking? Like maybe your relatives that died a long time ago, or some ancestors, right? Can you imagine creating a social network presence for people who never lived at the age of social networking? That's a new industry, see? Can you imagine like creating a social network for your great-grandparents and then saying, you know what, my great-grandparents lived in the same village as his great-grandparents. They could connect. They probably knew each other, right? They will be friends. So we create a linkage between people and then, you know, who sort of never lived in at the age of social networking, but could become friends. So this is kind of a strange world, but I've heard people in the social networking research community talk about this, and I find it fascinating.
For what reason? No, it's fascinating, yes, but why?
Morbidly fascinating. Well, because I mean, what else are you gonna do, right? I mean, look at all the amount of time people spend on social networking. It's this could give them spend more time on social networking, right? Look at the people who are obsessed with genealogy, right? There's like websites, right? Like Ancestry.com and all kinds of other like that will for money will let you trace your genealogy, and so people are obsessed. People are obsessed about themselves. Otherwise, we wouldn't have social networking, right? We're obsessed about them ourselves and every minute detail, right? So why not create accounts for people who are long dead and have them connect to each other? Could be fun. We already play all kinds of weird games like Second Life, right? Yeah. Anyway, enough said, but that's not what my talk is about. This talk is really about offline social interaction. So, but before we go there, let's talk about privacy. So OSN privacy right, is a kind of a, in a way, it's a kind of an oxymoron, right? Privacy on social network. I mean, a lot of people especially in my community, the privacy security research community, they make a lot of noise about how there's the privacy is such a terrible state and the erosion of privacy and leakage of privacy and all this other stuff. And it's like, yeah, it's terrible, horrible. But nobody wants to ask, very few people ask this question, is it reasonable to expect it? Is it reasonable to expect privacy from something that has the word social in it? Does it make any sense? Now, if it was antisocial, I understand. Like if you create a web to connect to nobody, nobody knows you exist, and you just create it for yourself, that would be antisocial networking. And then you could expect privacy. Nobody connects to you, no direct messaging, no links, no news, no hashtags, nothing. You just post to yourself. Oh, and say, oh, news from me. Wow. A message from me to me. Wow. Cool. That's antisocial networking. Then you could expect privacy. But expecting privacy here is stupid. Over here, like what? A few hundred meters away is a nice beach. Probably some of these beaches, well, they don't have nude beaches in Cyprus, right? Probably not allowed. Okay, okay, let's go to Crete. Okay, a few hundred kilometers is Crete. Definitely, I've been there. There ain't have nude beaches. You don't go to a nude beach, take your clothes off, and ask people not to look. But well, it's right. It's silly to ask people not to look. You chose to go to the nude beach. You chose to take your clothes off, and then you cannot ask people not to look. But why you go to the social network? Expose everything about yourself, post every time you have a successful trip to the bathroom, and expect people not to look. And not to comment, right? And they comment on it, of course. So I think expecting strong privacy or total privacy is absolutely silly. But how about expecting at least some privacy, like a little bit of privacy? Maybe it's not so silly. And then the next question that pops up is, if you don't have privacy, or you expect privacy but you don't have it, who do you blame? Do you blame ignorant users? And I think most of the time you'll be completely right if you say, well, you have nobody but yourself to blame. Nobody forced you to go to this, sign up for this social network. By the way, how much did you pay for this social network? Zero. You paid nothing. They gave you something, a kind of a vehicle for talking about yourself ad nauseum and ad infinitum. And they charge you nothing, and you expect something from them? I'm sorry, but they're not here to lose money. They do lose money, but they're not here to lose it. Eventually, they want to make money. So maybe you should blame ignorant users. Or, and these are not mutually exclusive, or you could just blame it on the centralized nature of the social network. I mean, it's a monolithic entity, right? I mean, yes, of course, you log into Facebook here, you're probably not going to Silicon Valley, right? There are replicated servers and so on, but it's still one administration. Every single social network has one central administration. Account management, everything is central. So every move you make, every step you take, right, is felt by them. They know. But that's part and parcel of social networking. We don't have examples of other types of social networking. Not that they haven't been proposed. They've been proposed. In fact, this was a pretty nice project in the Eurocom in France called SafeBook. And it was cute. It worked. And it was a P2P. Right? Remember P2P? It was sexy 10 years ago. P2P. And there was an actually working system called Diaspora. There was somewhere in San Francisco, a couple of idealistic geeks ran this, and it went exactly nowhere. I mean, maybe it had a few thousand users, and the SafeBook there was a startup that they tried to spin off, and it also went nowhere. Now, to me, that just indicates something interesting. I mean, I'm not an anthropologist or a psychologist, but I would venture to guess that there is something that doesn't work in P2P social networking. See, maybe you know that what does work, right? File sharing works because you get the tangible benefit. You click on that ripped DVD file, you get it, you watch it, you're done. It's a kind of a one-shot deal. You get it, you watch it, you're done. So you know exactly what is the benefit you obtain from it. Whereas from social networking, it's not clear. What does it mean to have your, Facebook? Imagine your Facebook page, especially if you had your account for a number of years. There's lots of info there, right? Tons of all kinds of multimedia content and boring stuff that you posted, and comments from friends and all this other stuff. And imagine it being striped across the internet with pieces here, pieces there. Maybe network coding applied, to kind of perturb it. And then what kind of reliability would you get? right? And then again, what is the psychological incentive for you to participate? I think that's the problem. Again, this is not a scientific guess. This is purely amateur guess on my part. So it didn't succeed, and I believe these things are not likely to succeed. Even though the concept underlying this SafeBook and Esper is very nice. Right. Now, why would you want to have social network interactions offline? Well, privacy is one reason, but that's at the bottom here. Even today, in the world which is quite well connected for the most part, we have places or situations where connectivity is poor. Right? Because remember, in order to do anything social on a social network, you must necessarily be connected to the internet. Right? Once you are disconnected from the internet, done. No social networking. Okay? It's just all or nothing. So if you have low bandwidth, intermittent connectivity, lossy links, how can you be social? Right? If you have expensive connectivity, if you are on a cruise ship, right? If you're going on a cruise to Antarctica, and God forbid, for 3 or 5 days you are without Facebook, or you have to pay, I don't know, $50 a day for some satellite internet access. That's terrible. Or if you're maybe spelunking or underwater diving and with your waterproof tablet you can't access Facebook. Or if you're in some shielded environment. There are also places, just regular places in this world where there is no connectivity. Like, you know, I was in the middle of Australia and good luck. You can't, even cell service is poor. But internet connectivity is almost non-existent. Well, there's some parts of Texas and Nevada in the United States. Just 2 examples, there are many more where the connectivity is terrible. And the other thing is, you know, OSN is a centralized service. If it goes down, if there's a service outage, you're what's called shit out of luck, right? You're done. You know, all of a sudden, there's no social interactions, and all this energy and nothing to do with it. All these millions of people needing to socially interact, and imagine Facebook is down. There'll be riots, revolutions, suicides. Yeah. Oh, I think there'll be suicides. Yeah. Suicides, yeah. Well, maybe not revolutions, but suicides, for sure. I mean, what if there is a giant denial of service attack on a social network? That has happened, and it will happen more, right? You can't reach it. And last but not least, what if your personal preferences, if you want to interact socially, but you don't want to connect to the social network? Now, this may sound contradictory to you. What do you mean, interact socially, but not connect? I'll explain in a minute. Let's consider an example. So if you are used to security talks, then you know who Alice and Bob are. If you are not used to security talk, meet Alice and Bob. Usually the 2 personalities that we use, A and B, or Alice and Bob, are the 2 people we just use as fictitious users. All right, so Alice and Bob, they meet physically, right, in some venue. Let's say like this, in a classroom or in a party or in a bar, they meet. They talk, and they discover some things in common. Like they both like balloons or fuzzy furry animals or square dancing or something like that. They discover some common things. People always do this, right? When they're thrown in a close situation, they try to figure out things in common. They discover some common things, and they decide to connect later. So when they go home at some point, maybe they get onto Facebook and they like connect to each other. Bob looks up Alice, or Alice looks up Bob, and then one of them gets the invite, clicks on the link, blah, blah, blah. They're connected, which is good for social network, right? Why does a social network exist, right? The more links, the more connections, the better for the social network. Okay? So if they connect, that's good. Nothing, OSN likes it. Or they decide that, yeah, they talk, but they don't really have enough in common to go on, so they don't do anything. Because neither one of them is interested, or one is interested, but the other is not. If Bob sends Alice a connection invite, she can just refuse or ignore, right? And then nothing happens. And notice that if they met physically, right, like let's say two people in this room, and later decided to not connect, OSN learns nothing. Right? The social network doesn't learn that Alice met Bob. Okay? So let's change this example a little bit. Now, not Alice and Bob, but OSN user X and OSN user Y meet. Now they meet also in physical proximity. Okay? So let's keep this in mind, that we're talking about an environment which is that has some physical proximity. They discover some factors in common. Maybe they went to the same school, maybe they're interested in the same art, whatever. If sufficient, if these common factors are sufficient, they reveal themselves to each other as Alice and Bob, respectively. Right? They talk some more, and they decide to connect later. Okay? Via the OSN. So at some point in time, on their own accord, one of them decides to connect, because now they know each other's names, right? So Alice and Bob decide to connect. The other one either rejects or accepts the invitation. Great. This is good for the social network, right? Social network is happy. Or if after they talk, at least one of them says, no, not interested, right? Then nothing happens. And ideally, this is my claim, is ideally in this case, the social network should not learn that they met. It's like if a tree falls in the forest, nobody's there to hear it fall. Why should anyone care? Right? Why should social network know that they met? It's not going to go any further. So let's remember this. So my claim is that these kind of private, offline interactions are good for the social network, right? Because they can result in more connections. And they're good for the users as well, right? Because users can either choose to connect and become friends, or whatever they're called, and on the other hand, become friends, or they can choose to go their separate ways and nobody learns that they met. Now, remember I remind you, we're talking about an environment where there's some physical proximity. Physical proximity doesn't mean that Alice knows who Bob is. It could mean an environment like a movie theater or a classroom, where you can talk to somebody. So let's say you all have laptops and smartphones, and some guy is standing there giving you a boring lecture. You can multitask, right? And use your smartphone to social network. So imagine you are actually talking to somebody right now. You don't know who you're talking to, but you know they're nearby. Right? That's what I mean by physically proximate. So you're not going through the social network, right? You're not connecting there. You're talking directly. Okay? Now this kind of sets the stage for the rest of this talk. So this is my claim. It's good for everybody. If you have this kind of offline interactions, then it can be good for everybody. So here's again a very generic scenario. Alice and Bob are near each other. And there are many examples where they could be near, right? They could be on the same music venue, it could be in the same football stadium, they could be in the same classroom, they could be in the same restaurant, they could be on a plane. The plane is a good example. You're stuck in this metal can for hours on end and there's very little to do, right? And then they don't know each other's real identities. But they discover each other's presence as the users of OSN, right? So imagine like every one of us has a device, like a smartphone, and we broadcast, hey, Facebook user here. And somebody else broadcasts the same, Facebook user here, and we connect. We don't know who we are, but we can connect and then chat, right? And if we decide that we have enough in common, I can tell you my name, maybe you can tell me yours, and then we take it from there. Anyway, so we discover each other's presence, then compare, and this is the part where it gets a little more interesting. We don't need to actually chat, right? Like physically involve ourselves. What we can do is, because we both are part of the social network, like Facebook, we can have our smartphones or laptops send each other some kind of profile features from our social network, and those features can be compared to determine whether there's enough in common or not. Okay? So for example, I could say, well, I'm going to go on this plane ride. It's going to be 10 hours from London to Los Angeles. I'm being bored and I'm not going to be able to sleep. So let me put my phone in this kind of a social mode, okay? Like with Bluetooth in social mode. And let me broadcast myself as a Facebook user. So let's say if there's somebody else out there, maybe it's Michael, maybe it's one of you, I don't care who it is, is a Facebook user. And what happens is you broadcast the same thing, and our phones receive each other's profiles, they compare, and then all of a sudden there's a message that pops up saying, hey, there's somebody here with whom you have 3 friends in common. Would you like to talk to them? Now it's purely offline. No social network is involved, right? We're just talking directly. I don't know who you are, you don't know who I am, but if we both decide to talk, we reveal each other's identities to you. And we take it from there. We can also not talk. Okay? It's up to us. But so this kind of paves the way for the rest. Okay, so you see, this is what it means. They privately kind of compare. Now, privately is important because if I just send you my profile, like if I take a copy of my Facebook profile that I've downloaded previously, and I send it to your phone, and you do the same for me, where's privacy? I learn everything. I learn your name, your Facebook name. I learned your friends, right? Because that's not going to work. So this is where some cryptography becomes useful. What we do is that we insert the special protocol, cryptographic protocol, that allows us to compare profiles in such a way that the only thing we learn is how many things we have in common, or what things we have in common, but not anything else. Okay? So in a very simple case, think about it like this. You kind of send me an anonymized set of your friends, and I send you an anonymized set of my friends. Somehow we compare them. We learn who the friends in common are, if any, but we learn nothing else. Okay? So that's why it's privacy preserved. So if there's insufficient number of things in common, the protocol stops. We're done. We don't talk any further. Otherwise, we can choose to reveal each other's identities. We can chat, right? We can record things. Okay, time passes, and then later, optionally, only if we both want to. Whenever we land, the plane lands or the ship docks, we're back to the land of connectivity, then we can reconnect or connect on the social network. So you see the scenario now. So now, the next question is, so if we want to support this kind of interaction, yeah?
So you mentioned offline social networking.
Yeah.
You insist on that because if it was online social networking, the problem would be easily solved.
Totally easily solved, because the social network itself could say, you know what, I will be the matchmaker.
Yeah.
I will be your trusted third party. But I don't want them to know. I don't want them to know that I'm talking to Alice if our conversation is going to lead nowhere. Or if I don't have enough. I don't want them to be, you see, this is what I meant earlier, but can I have at least a little privacy? Just a tiny bit? I mean, they already know everything about me, but can I have just a little bit? Like, do they need to know everybody I meet in the same room? So this is my point, right? So whose job is this? Should this kind of social offline interaction be supported by the OSN itself? And by the way, that doesn't mean it has to be online. But should OSN itself kind of facilitate this interaction? And certainly, there's a good argument for this. Right? If LinkedIn or Facebook were to help us here and allow us to extend their service into the world of offline, like when we are on the plane or on a ship or at a concert, whatever, they would benefit from it, right? Because more people would meet and more people will form connections. But would we trust them to keep these things private? Would we trust them to keep our conversations, our interactions private? Because I may be, let's say, in this plane or the ship for a long time. I may be chatting or having these kind of tentative connections with a lot of people. Does the social network need to know about this? And if they tell me we don't keep this information, can I really trust them? I don't think so. So that's an argument for making it a separate service. And this is the way we did it. Although this is much easier. This is much easier.
Why can't we trust them separately?
Because it's they don't have an incentive to. They can tell you, we don't record it, but if they do, what are you going to do about it? You can't blame them, right? It's their. The more information about you they collect, the better off they are, right? I mean, they have.
The separate service too, right?
Well, that's okay, but the separate service, if it operates independently from social network, has more incentive because that is the only selling point of that service. This is the only thing their reputation would be based on.
Okay.
So they have a lot more to lose. Do you see? Either it's all or nothing. Either they preserve your privacy or they don't. But if they don't, they're worth nothing. Well, the social networks say, you know, oh, you bad people at Facebook, but I still gotta use Facebook because, you know, I'm tied to Facebook. You know, I would die if I could. Yeah. Okay, so yeah, this is the approach we took. The other problem is, well, you want privacy, right? So you want Alice, these users X and Y to talk to each other. But if we don't have any idea that they are actual social network users, then you could be talking to a wall. You could be talking to a troll, right? You could be talking to some weirdo, right? Like, for example, imagine some teenager, right, is talking to somebody who's also pretending to be a teenager, but is really a creepy old guy, you know. I don't know, maybe this sounds better in the United States. We have more creepy old guys. But the idea is basically, you know, this old saying that on the internet nobody knows you're a dog, right, or a hog. So this is a bit of a funny thing to say, but we still need to be able to verify that whoever it is we're talking to is a bona fide, is a genuine OSN user. Okay? So when Alice and Bob, pretending to be users X and Y, when they're talking to each other, they should be assured that they're talking to a real social network user. They don't know who, but has to be a genuine user. So that's an added requirement, right? So it motivates kind of a new service, which actually is not difficult to achieve. So these were our design goals. We wanted to support this kind of offline interaction. We wanted to have anonymity with respect to peers, right? This means when you are talking to somebody, you are anonymous. Now this is debatable. You see, I put it in place, debatable because actually anonymity is a strong concept. It means that if you and I meet the first time, I don't know who you are. But if we meet a second time, I also don't know who you are, and I don't know if you are the person I met the first time. That's, roughly speaking, anonymity. What that means is that if we are on the same plane or ship for a long time, I may be talking to you many times, and I'm getting quite annoyed because I know it's boring, right? I'm talking to the same person. So maybe anonymity is not desired here, but rather pseudonymity is better. Which means that if I talk to you the first time, I don't know who you are, but if I talk to you the second time, I recognize you as the person I talked to before, and I want to waste my time on you because I have talked to other people. And I also want to keep privacy with respect to peers, meaning that if I have my social network profile that I'm using to prove that I'm a real social network user, I don't want to reveal information in that profile. Right? I want to convince you that I'm a genuine user, but I want to tell you anything about my friends, or where I went to school, or what colors I like, etc. I also want to keep my interaction, this kind of offline interaction, completely private from the provider. Right? Remember, this is the most very important. I don't want the social network to know about these interactions that occur offline. I want to facilitate what's called a spillover, which means that if the interaction offline is mutually beneficial, it should easily translate into a connection on the social network later. Okay? This means that there should be security, that I should be a genuine user. I mean, both parties participating in an interaction should be genuine, that they should be authentic, and that the ownership of their profile should be asserted. This should not be specific to a social network. Ideally, this kind of application, this kind of service should be agnostic and independent of the social network, and it should be opt-in, right? You shouldn't force people to do this. If if I like these kind of offline interactions and I'm bored on planes and trains, great. But if you don't want to participate, that should be your choice. So this is our sort of result. It's called unlinked because it's a play on words because we built it on top, originally on top of LinkedIn. And we built it on an Android smartphone platform with essentially 2 components. And I'm going to sort of try to be careful here when I explain these 2 components. The first component is the app, right? So you download it. I don't know if it's still on Google, on Android Marketplace, but it was at one point. I think it's not because it was a prototype. We're just trying a user study. So this ULA app, you download it, and you essentially connect. It works with LinkedIn. It only works if you have a LinkedIn app installed on your Android phone. And it implements, never mind these acronyms, it implements 2 cryptographic protocols underneath. One is two-way, what is called authenticated two-way private set intersection, and the other one is called authenticated two-way private set intersection with cardinality. This is crypto speak. I'll tell you a little more later, never mind right now. It uses Bluetooth. So right? Because remember we talked about physically proximate communication. Now ideally we would use something else. Bluetooth is a very clunky, unreliable medium, as you probably all know. It works in a setting like this, a classroom, it works on a bus, but even on a plane, from the, let's say, economy section to business, it wouldn't work very well. And it certainly wouldn't work on a ship or anything bigger than that. And the problem is that Bluetooth is very limited range. It doesn't really allow point to multi-point communication, right? You can only do point-to-point. But it has a host of other problems. Ideally, we would use something like Wi-Fi, but there is no good peer Wi-Fi, right? There is the Wi-Fi Direct, but it's poorly supported and incompatible across different smartphone platforms. So this is a problem, right? Ideally, there should be a longer range peering protocol, right? Whereas most of us use Wi-Fi in its infrastructure mode, right? We connect by access points. Now, our prototype also supported the infrastructure mode of Wi-Fi, but that's kind of silly because we don't want to use the infrastructure. The idea was to talk directly. So for the sake of this conversation, for the sake of this presentation, imagine Bluetooth. Yeah. This is what I meant. The Wi-Fi Direct and ad hoc mode is something you can do with your laptop, but it doesn't work, at least back then, did not work with smartphones at all. Okay? I don't even think it works well today with smartphones. Can you do Wi-Fi Direct? I would be very surprised. Between 2 smartphones. You can? For the same brand. Now that's an Apple? Yeah. Yeah. Okay. That's like you can do FaceTime, right?
It works on Samsung too, but it has to be the same brand and very new phones.
Okay. Okay.
For given applications.
I see. Well, that's what he's saying, right? So it has to be the same, exactly the same model, the same app.
For a given app.
Well, that's better than it was, whatever, 2-3 years ago, but it's still not something you can say that my Nokia Android can talk to your Motorola Android can talk to your iPhone, It's not the case, right? So that's the problem. We have these you cannot just say, oh, it's going to be only for iPhones. In fact, iPhone was a really terrible platform to work with there. They're really closed. So that's why we picked Android. But even in the Android world, Wi-Fi was poor. Bluetooth works. If it works across platforms. But it's very fragile. It's also not very fast, right? Bluetooth, just because of its channel characteristics, is not very fast. Wi-Fi is quite a bit faster. So again, we have this app, okay? And basically this app is the one that interacts with a peer, right? It discovers the peers and interacts with the peers. But we also have a server. You say, but wait, how can you have offline interactions and have a server? That is a contradiction. Not true. At some point in your life, you must be online, right? how did you register for the social network anyway? It means a proof, right? At some point, you have to be online. Which means that at some point, you have to register with our service. So we provide, remember I said there was, I at least tried to argue that this kind of offline interaction should be supported as a separate service. Well, somebody has to be able to certify that you are a social network user. And so we provide this server as a standalone server that whenever you are online, you register with our server once, and our server certifies your social network profile and gives it back to you. And now you can go offline. Does that make sense? Huh? But you must, anyway, at some point in your life, be online, right? You must, right? You cannot be offline all the time, right? How did you become a social network user? You have to be, right? So that's my point, is that whenever, the one time you're online, it doesn't have to be at the same time I am online. Just whenever you're online and you register with us, you want to download, you had to download our app, right? You had to be online to download the app, right? So at that time, when you download the app, you also connect to our server. And what you do is, again, I'm jumping a little bit ahead, but what we do is we say, okay, log into LinkedIn. You log into LinkedIn on the LinkedIn app. And then our app pulls what's called an OAuth token, an authentication token from the LinkedIn, sends it to our server. Our server contacts LinkedIn using the token you provided, pulls a copy of authentic profile, because we cannot trust you, right? We take it directly from LinkedIn, and we certify that copy of your profile before, but we do something with it, because we cannot just certify it as is, because it leaks information. Do you follow what I'm saying? Right? And returns this to you, right? So now you have a certified copy of your own LinkedIn profile, certified by us. Now you can go offline. Okay? So if I convinced you having server is not a contradiction, because you had to download our app and had to be online. All right, so this is something you use very infrequently. You only use it, ideally use it once. You would want to use it more than once if your profile changes, because you may have to recertify the profile. Okay. So this is like the phases of operation. So we have phase A, which is not related to us. This is, users register with a social network, right? At some point in time, Alice, Bob, Charlie, they become members or create accounts on the social network. But this phase B, that's where we get in. This is where Alice, the user, installs our app, logs into the social network, in our case, LinkedIn, right? And using the OAuth token, allows our server to pull the copy of the profile, extract certain features from it, anonymize the profile, because it cannot be plain text, and then sign it and return the result. So this is the important thing. Now at the end of this phase B, Alice is ready to go offline. She has our app, and she has this kind of a blinded or anonymized version of her profile. And now at some later point, at phase C, this is where this offline interaction occurs. The Alice and Bob discover each other via, in our case, via Bluetooth, exchange information, compute things in common, if any, and decide at some, perhaps much later point, to connect on the real social network. Yeah?
Where does computation take place?
Where?
The computation takes place.
On their devices.
Separately,
Yeah. As part of this interaction, I mean, look, your phone is a full-blown computer, right? Has, well, at least my Android has a bunch of cores, right? Surely your iPhone is powerful enough; it can do a few crypto operations, right? So yeah, it's not a lot of computation actually. It's not very heavy. And then, like I said, you may or may after this nothing might happen, or they can connect at some point on the social network. Okay, so we try to be independent of the social network because we use this OAuth framework, which is this kind of it's what used for also for single sign-on, but it's quite useful. It's a standardized, quasi-standardized feature. There is for every social network, for every major social network, there's something called the Profile API, right, that allows you to access a user's profile. Given users OAuth token, valid OAuth token, you can access their profile, some features of the profile. We try to be independent of the communication medium. I mean, rely as little as possible on Bluetooth, but like I said, there isn't very much we can do, I mean, other than use the infrastructure Wi-Fi, but then it's not truly offline, right? Because the Wi-Fi, you know, an access point implies that you are in some place where you can get internet access. Not always, maybe on a ship you don't, right? So it might be useful in a larger place which is isolated. Or maybe like one of those desert festivals we have in the US, like Burning Man, where it's like thousands and thousands of people gather in the middle of a desert to you know, roll in the dirt and pee in the bushes, you know, and listen to music. Yeah, if you've never heard it, it's fascinating. Oh, look up Burning Man. It's happening in a couple of weeks.
Music festival.
Oh yeah, yeah, in Nevada, in the desert. Yeah. Still not. It's not too late. You can still join. Right. So it's it's offline, proximity based, and what's underlying there, the actual meat of this app is a couple of cryptographic protocols. Right, and even though, and these protocols, of course, are very specific in our case, but we try to be as independent because they come in various flavors. And we use a particular version, which I'm not going to bore you with, because this is crypto. And the terminology here is OPRF, oblivious pseudo-random function-based Diffie-Hellman protocols that compute this called private set intersection. But the ways these protocols work is that and so I'm abstracting away, forget about social networking. The way private set intersection protocols work in cryptography is you have two parties, Alice and Bob, each with the input of a set. Like Alice has a set of integers, Bob has a set of integers. They don't reveal them to each other. They input those respective sets into the protocol, and out comes the intersection. Right? And neither party learns anything else but the intersection. That's the trick about these protocols. And you can see, right, how this would fit into what we're trying to do here. Because typically, I mean, you can compare any kinds of things, but the typical thing, or the most intuitive thing to compare with social networks is like friends or connections, right, on LinkedIn. But there are other things. You don't have to just compare friends or connections. You can compare employers, right? You know, on LinkedIn, you have like job history, and you put employer names. So that's also something you could compare, and like say, you worked for IBM at some point, I worked for IBM, that's a common thing in common. Maybe, in fact, that is more important as a common factor than the fact that we have both her as a friend, right? So, or maybe we went to the same high school, right? That's also something. Education, people put in LinkedIn, right? You went to the CUT, I went to the CUT. If we meet in Limassol, who cares, right? Important thing. Common factors are sometimes dependent on geography, right? In Limassol, if you meet another CUT grad or student, you wouldn't give them a time of day. But if you are traveling in New Zealand, in the South Island, you know, climbing some glacier, and all of a sudden your phone says, hey, there's a CUT graduate nearby. You're like, oh, damn. Wow, I want to meet this person, right? I mean, that's how we all operate, right? We're only interested in people with something in common who are far away from home. Yeah, anyway, so enough said about crypto. So we achieve, I'm going to make it quick here, we achieve all these sort of protocol correctness because and I can point to some paper where we show that, that this holds. We have privacy with respect to peers, meaning that nothing is revealed except the intersection. Now you can make it even more private if the only thing you run is what's called the cardinality protocol. Cardinality protocol is like the private set intersection, except it doesn't tell you who is in common, what is in common. It tells you how many things are in common. So this is a different privacy setting. It allows me to say compare my profile to Michalis, and it will tell us both that we have 7 friends in common. Now, if he only has 7 friends, that tells him everything, right? Because he knows exactly who. But let's say he has 100 friends, I have 50 friends. The protocol outputs 7 in common. We don't know who, right? That's better for privacy, right? But why would you use one versus the other? Depends on our own privacy policies. For example, my own personal policy might be, I'm happy to talk to anybody or connect to anybody with whom I have more than 5 friends in common. Michalis may have a different policy. He might say, I'm only interested to talk to somebody with whom I have 5 friends that I can see. I want to choose based on the actual 5 friends we have in common. Because, if it's these 5 friends, nah. But these 5 friends, yeah. Okay? It's a personal choice. So depending on who wants more privacy, we would pick the right protocol to run. And in case you wanted to see some crypto, okay, this is just, too close to 2 o'clock for you to get into, but this is actually the very simple protocol. This is what happens between the user and our server when they register. So what the server does here is he returns. The important thing here is he signs what's called the blinded profile of the user. And everything in that profile is like a feature, if you will. Like one of those is like a friend or a connection. And this denotation means blinded. So it's the vector of these features is signed and given to the user. And now the user can in turn later insert this into the private set intersection protocol. And this I will not go through. I'm sure you're very sad, but this is the actual authorized private set intersection protocol. But if after lunch you are interested, I will be happy to explain in excruciating detail. Yeah, this is the protocol, the ULA. This is the app-to-app protocol that happens offline, this peer-to-peer. And never mind that. This is the cardinality protocol. All right, now the policy. So one of the interesting sort of usability-related things is how much do you want to bother the user, right? So we try to, if you want to engage in these kind of offline interactions, and you're in a place where you have people with potentially a lot of things in common, this app will be very annoying. Right? They will keep telling you, oh, there's somebody here who knows you. Oh, somebody here with you have a friend in common. Oh, there's somebody here from the same high school. Who cares, right? So ideally you don't want to be bothered by this app. So you need to actually configure it so that it has this kind of a dynamic policy. Like if you're, for example, remember we discussed how if you're at home, you're likely to be around people with many things in common. But far away from home, you're much less likely to meet people with things in common. So you want to configure your app so that when you're home, the threshold is high for things in common. And when you're away from home, the threshold is low, right? And so that's actually kind of an open area, right? How to do it well. We provide some examples, but ideally your app on the phone should learn how far from home you are. Use location information and gradually adjust the threshold for how many things in common you should have before you connect. Yeah. Anyway, moving right along, we have by default we just offer basically 3 types of policies. One is open, which means no privacy. So this is where you don't care about privacy. You just want to use an offline app. Low privacy means, oh, let me connect to anybody with whom I have 1 friend in common, or 1 school in common, or 1 employer in common. This is, again, using LinkedIn terminology. Or at least 3 friends in common, right? So this is kind of what's called low privacy. And then medium privacy, medium threshold is like this, 5 connections and 1 institution. Anyway, not important. This is just an example. Policy is actually a complicated subject, and allowing users complete freedom can result in nonsense or like no interactions at all, because users who are privacy conscious may set it too high and they'll never talk to anybody. Users who don't understand how this works well will configure it too low, and then they'll be constantly annoyed by the app saying, oh, you have a friend there, potential friend nearby, potential friend nearby. And some policy is nonsensical. Right? So we've actually had users configure policy that made no sense, that contradicted itself. So that's a tough thing. As far as coming back to computation, right, and the smartphones, this is 2.5 years ago, using a very average, actually Google phones, right? So we use these LG, I think they were LG, the Google branded phone, Androids, and the input size column here. This is just a performance slide. The input size here is basically the number of features in your social network profile. You can think of it as a number of friends or connections. So when you have very few friends, things are very fast, right? This is in seconds, right? The setup time to set up the app and the offline time in milliseconds is, sorry, this is seconds, this is milliseconds, so this is negligible, bandwidth is negligible. Now look what happens when you are very social. If you have 10,000 friends or connections, which is probably a bit much, right? But when you have 10,000, it takes about a minute and a half to set up the app, which is pretty healthy. Never mind signatures, nobody cares. But the offline time is 15 seconds to engage in a protocol with somebody. So you are offline, so you're probably not in a hurry, but still 15 seconds is a long time. All right, so more likely to be here, this is probably on the high end of socialness, right? People who have like 1,000 connections or 1,000 friends, right? There it gets a little more realistic, so it's about 9 seconds to run the protocol. Today it would be better, right? So with the quad core, we use dual core Androids, right? So now with quad core it would be faster. But this is just to illustrate it's practical. And this is the thing, well, screenshots I'm going to skip. Boring. You can, one of the things with this app that's funny is that if you actually meet somebody who's already your friend, you're wasting your time, right? So right, because you could be already in each other's connections or friend list, and if you're running this protocol, why would you do this, right? It's silly. So we have this called early friend detection, so we try to make sure that if I am in your friends list, or you are in my friends list, we detect this early and abort the protocol. Just say, hey, it's me. Don't pretend you don't know me. Right? We also try to, if they're in an environment where communication is inherently insecure, subject to denial of service or impersonation, we can have an extension that run what's called a Diffie-Hellman key exchange, authenticated Diffie-Hellman key exchange before engaging in the protocol. If you like unlinkability, this is related to anonymity I mentioned earlier. If you want to be unlinkable, that is, you want to make sure that you and I meet twice, and if we do, we don't recognize each other. It's possible to do so, but in this case, whenever you register with our server, you have to obtain not one, but multiple blinded certificates of your profile, which will be unlinkable. And there's no escaping the fact that simply Bluetooth MAC address leaks information, right? So if I meet you more than once, and you don't change your MAC address, you know, who cares? All the crypto in the world is not going to save you. So you need to be able to change your MAC address, and not all devices allow you to do that. And even if you do that, there's still, the bad news is that there's been quite some research or some work published on interface fingerprinting. And so even if you change the MAC address, apparently given enough communication, then I can identify your physical radio interface just on the basis of its like various physical radio characteristics. Okay, so timing, the various parameters like RSSI, loss. I'm not into this space and this communication security at the physical layer, but I know that there's been quite a lot of depressing work in this area. It's very hard to hide. Yeah, so that's the bad news. In case somebody misbehaves, that's another interesting feature here, is if somebody misbehaves, like aborts the protocol or something like that, you can trace them later. That if somebody, like say, you engage with somebody anonymously, like offline, and they start sending you, let's say, threatening messages. You don't know who it is because you haven't revealed each other. But if you record the conversation, including the cryptographic messages that you exchanged, we can later de-anonymize them if you go to the server. And our server will be able to de-anonymize them. Yeah, it's kind of an escrowed anonymity, if you will. Yeah. We haven't generalized it to other OSNs, and part of the reason we did not is because not all of them allow you this kind of a free access to the API. Some of them you have to pay. Right? Some of them don't allow it at all, and some of them, like Facebook, you have to pay.
It's free. I think for Facebook,
not, or maybe it's a
list and then
yeah, but there's a limit, right? So some of the networks, I mean, maybe Facebook was one of those. You could get free access and pull a certain number of user profiles, but then once you exceed the threshold, you have to pay. Like I remember that this was a problem for us because we had to be able to pull unlimited number of profiles, and they consider it to be kind of a threatening behavior when you do that. All right. Let's see where we are. There is some. So we were not the first to look into this, or not the only ones to look into this. There's been some efforts. In fact, one of them was by one of my former students. If you're interested in this topic, there's this work. These two papers look into a similar problem, but their incentive is very different. They're not into offline interactions so much, but they're into the world where suppose two people aren't physically near each other, and one of them wants to use the other as a gateway to get onto the internet. And so you only want to do that if you have enough friends in common. So there's some common motivation, but the application is very different in nature. But worth reading if you're interested in this topic. So to summarize, what I showed you is, or tried to show you, this unlinked application, which is something that supports offline, private social network. Actually, shouldn't be O here. Private social network interactions with reasonably strong privacy, at least in that small corner of the world, you can achieve reasonably strong privacy. Question is it desired, right? So I'm a privacy researcher. To me, this is kind of intellectual curiosity. This was a matter of intellectual curiosity. Can it be done? It's not my first question, right? Will people use it? But it is an important question. We haven't answered that. So we never did user studies. So this would be one of those things one could study with the real users, or one could study with probably Amazon M-Turkers, because that way you could reach a much broader audience. We haven't done it. There's also a very fundamental problem, and this is the disadvantage of doing it the way we did it, which is outside the social network. Remember there was a slide earlier on, I said you could do it with the social network or outside. And I said, oh, we want to do it outside because that way we know we have better privacy. But the disadvantage is we have this major headache, the bootstrapping problem. I bet you that if today Facebook or LinkedIn decided to support this kind of offline interactions, they could do it like this. They simply release a new version of the app, right, for your smartphone that includes this feature. You wouldn't even know it. They'll just force you to download it, right? And then you could say, hey, by the way, if you want to, you can opt in to this new feature. But the code is already there, right? You see how easy it is? Whereas for us, there's a bootstrapping problem, right? If we have our own app, it's not you can go and download it, but who are you going to talk to? Right? It's a bootstrapping problem because unless you find other people that have the same app. Now, of course, I suppose Tinder had the same problem too, but the motivation for Tinder was a little bit different. Different kind of interaction, right? Yeah. So that's the end. Thank you very much. Any further questions?
One suggestion. Maybe you can use the app whenever you want to, not so you don't get the notifications often. Because you said that is the problem.
Yeah.
I open it when I am on a flight and then see which is online.
Well, I mean, that's what we envisioned it. We didn't build this app to be with a rich enough user interface, but ideally we envisioned it like this. Yeah, that you go on the plane, you say, okay, I'm flying. Okay, I'm flying from Larnaca to Athens. I'm going to keep it the same as I keep it at home. You say I live in Limassol, I'm going to keep it the same. But in Athens, I'm going to change a plane and go to London. Oh, now I'm going to set it lower threshold, right? Because I'm less likely to meet people with whom I have stuff in common.
Okay, yeah, with threshold, fine as well.
And then I'm backpacking in Patagonia, and then I'm going to make it really low. Anybody with whom I have anything in common would be great, right? Okay, then the next question is, where is lunch, right?